Michael Faraday by Maggie and Miranda Wells. Faraday's historical influences. Before Michael Faraday's achievements and discoveries, many important influential scientists came prior to him, inspiring Faraday in his thoughts and actions. In the 18th century, Ruggiero Giuseppe Boscovich suggested that atoms were points of mathematical origin enclosed by fields of positive and negative energies. He was able to further devise that a true element was made up of one point, and elements that were of a chemical nature were made up of many such points. This led to Boscovich's proposition that molecules were simply a composition of numerous atoms and elements that needed to be subject to an exacerbated amount of tension, strain, or pressure before the bonds within these molecules were destroyed. Ruggiero Giuseppe Boscovich's studies were a tremendous inspiration to Faraday. Boscovich's experiments and findings became the main idea of Faraday's works, leading into the fields of electricity. Similarly, Antoine Lauret Leviezer made headway in the field of chemistry, creating a few simple principles that would guide and inspire Faraday in his works. This included theories regarding oxygen as a unique element, with it being solely responsible for the combustion of elements, along with acting as the base ingredients in all acids. This theory contributed greatly to Faraday's work as a chemist throughout his apprenticeship and throughout his later studies in life. Faraday studied under great chemist Humphrey Davy in the 19th century. Humphrey worked closely with Faraday, teaching him about the history of chemistry and his works, such as elements and atom composition. Davy discovered sodium and potassium through the use of electrical energy running through a galvanic battery, which inspired Faraday when looking into his works with diamagnetism and Faraday's cage. This experiment led to further discovery of hydrochloric acid, chlorine, and determined that oxygen was not a base of muriatic acid. Davy was able to elaborate on Boscovich's hypothesis, identifying that the properties of a chemical compound were not determined simply by elements, but the composition of these elements within a molecule. This apprenticeship taught Faraday all he needed to know about chemistry and gave him the drive to develop his own hypothesis regarding many of the trending theories in the science world at the time. As a result, Faraday finished his apprenticeship with all the knowledge, if not more knowledge, of Davy, and continued in his endeavours as a scientist. Diamagnetism. One of Michael Faraday's greatest and very recognizable achievements is that of diamagnetism. In 1820, Faraday created a glass lens with high refractive index that was used throughout this experiment as an indicator for success or failure. When a plain polarized light was passed through the glass and an electromagnet was run parallel to this beam of light, the polarization was rotated. This was a success for Faraday. However, when the beam's direction was changed, the rotation of the beam was not altered, which was an unexpected outcome. Faraday was able to conclude that in comparison to his first beliefs, the tension was present in the magnetic lines of force rather than in the molecules of the glass as first hypothesized. This drove Faraday to continue his works, and some years later, in 1845, demonstrate with the use of this glass and prior hypothesis that materials would respond to a magnetic field in a diamagnetic or paramagnetic way, regardless of the composition of this material. Faraday named this effect diamagnetism. With his success, Faraday continued to develop his hypothesis and evolved into the field theory in 1850. This theory stated that space was in fact not just nothing, but a medium able to carry the strains of both electric and magnetic forces.
Electromagnetic rotation was discovered by Michael Faraday in 1821 following a discovery found by Hans Christian Ørsted. Hans found that an electrical current flows through a wire and it creates a magnetic field around it, and that magnetic field had a circular force. To prove this, Faraday conducted his own experiment using a mercury bath. The result of this experiment turned out to be the first electrical motor. From this, he then concluded that electricity was a vibration that was transmitted as a result of tensions that were produced in the conductor. His belief of electricity was contrary to the popular belief that it was a material fluid that flowed through wires like water through a pipe. Faraday's most iconic invention is the Faraday cage. The cage is able to block exterior electrical fields and is able to protect electronics from electrostatic discharges and radiation from the outside. However, the cage is unable to protect the interior from Earth's natural magnetic field. Faraday first created this cage by coating an entire room with tinfoil and used a generator to create a high voltage discharge that would continually strike the outside of the room. He found that there was no electrical charge on the inside. The way that the cage works is that the electrical field that is outside the cage leads to a reorganization of electrical charges which stops the electrical field on the inside. An example of this in a modern setting is the microwave door. The door keeps the microwaves inside the microwave itself but allow light from the outside to pass through the holes in the screen. 10 years after the discovery of electromagnetic rotation, Faraday discovered electromagnetic induction. Electromagnetic induction is the process of using magnetic fields to produce a voltage and, in a closed circuit, a current. The way he found this was by moving a magnet in and out of a wire coil, and that created an electromotive force, otherwise known as a voltage. By doing this, it produced a current. To make more sense of this notion, he created 3 laws to go with it. The first law involves increasing the number of turns in the coil. By doing this, the total electromotive force could increase due to more loops within the coil. The second law includes increasing the speed of the motion between the coil and the magnet, meaning that if the same coil was to be passed through the same magnetic field and its velocity was increased, the coil could cut the lines of flux even faster, so then more electromotive force would be created. The third law includes increasing the strength of the magnetic field. So if the coil were to move at the same rate but through a stronger magnetic field, more electromotive force would be produced.
Those he influenced. Many scientists were able to draw on Faraday's many hypotheses, experiments, and findings to structure their own learning and discoveries, including scientists Maxwell, Sturgeon, and Joule. The glass created by Faraday was able to be used to drastically improve the power and effectiveness of telescopes during that era, subsequently allowing scientists in the field of astrology to make tremendous headway with the ability to classify planets and the solar system in more detail. Also, further developing hypotheses of the composition of the universe with the help of this new glass. Faraday's advances in diamagnetism and electricity influences well-known physicist James Clerk Maxwell. Maxwell spoke about where the foundation for his mathematical theory of electrical and magnetic fields came from in the late 19th century. This was Michael Faraday's works in the field of diamagnetism. Maxwell mathematized Faraday's theory and hypothesis to create his own classical field equations and make many advancements in the field of electromagnetic radiation. Faraday paved the way for other prestigious scientists such as William Sturgeon and James Joule to use his theories, methods, and findings to further improve and develop the electrical motor and its uses in society. This greatly improved society's quality of life in the 19th century and gave scientists the foundation they needed to make further advancements in their field well on into the 20th century.
In summary, Faraday was an incredible scientist who made many discoveries over the course of his life. This included making impacts in astrology with his glass lens and physics with the discovery of diamagnetism and subsequent electrical models such as Faraday's cage, the electric motor, electromagnetic rotation, and induction.
During the course of Faraday's career, he was influenced by a great many of people, including Ruggiero Giuseppe Boscovich, Anton Laurent Leviezer, and the most influential Humphrey Davy. Furthermore, Faraday inspired the likes of William Sturgeon, James Joule, and James Clerk Maxwell to pursue and improve on his theories, impacting society in a positive manner well into the 20th century and beyond. And these are the references used throughout this assignment. Thank you for listening.